Hello and welcome to ATARC's webinar series. Today, IT topic experts will be focused on discussing how edge computing is a must for both 5G and IoT success. My name is Kirsten Patton, and I'm the Working Group Program Manager here at ATARC, and I have the pleasure of moderating today's panel. Welcome to all of the attendees, and a special thanks to Brian Bishop, Rebecca Umberger, Lindley Hensarling, and the rest of the Aerospike team. This afternoon, we are going to hear from our panelists, which will be followed by a Q&A where we will pop in a few poll questions and then answer your questions as they come through. Before we begin, I just want to encourage the audience to submit questions of your own in the Q&A section of this platform. We'll be going through them during and throughout the panel, so please send them in. And please also remember to answer the poll questions as we go through them to ensure that you receive your CPE credits for attending today's session. I would now like to introduce our panelists for today. If you would all please come on camera and go ahead and unmute yourselves. First up, we have Vincent Sritapan, the Cyber QSMO Section Chief at the Cybersecurity and Infrastructure Security Agency. We also have Dan Massey, Program Lead 5G to Next G Initiative at the U.S. Department of Defense. Next up, Kenny Miltenberger, the CG Cyber Blue Team Branch Chief at the United States Coast Guard. And we also have Lindley Hensarling, the Chief Strategy Officer at Aerospike. So we have an awesome lineup today. Thank y'all for being here. And first, I would like to give the opportunity for each of our panelists to share a little bit more with our audience up front about some of the projects that you're working to or anything you think would be of interest to our audience as it relates to the topic today. If we could hear from Vincent first, please.
Great. So, hello everyone. My name is Vincent Sritapan. Thanks for having me today. As mentioned, I'm the section lead for Cyber Quality Service Management Office, also known as QSMO. Primarily, I work on everything from technology management for existing designated services all the way to service innovation to include things like mobile security. I'm also the 5G cybersecurity R&D lead here at CISA. And then I co-chair the Federal Mobility Group. So from those different vantage points, I could tell you some of the things we're working on. I think that will be great. And so past work, I think from Federal Mobility Group back in November, we published Working Across with DoD, other federal departments and agencies, which is a framework to conduct 5G testing. Specifically, you can find that on CIO.gov, but the Federal Mobility Group did push that out really to help educate departments and agencies and others on what is 5G and more on, it takes more than just, a desire to do it, right? The idea that 5G is just a hype. We push very much so to show a process in which people can think through what it takes to test, what the standards are in place in the roadmap towards there, what indoor-outdoor spectrum considerations that they would have to consider. So I'd start with that one on the framework to conduct 5G testing. What we're working on now, I'll say, and we'll talk more about this actually with folks like Dr. Dan Massey here and even some considerations from NIST, is this idea around investigating the security evaluation process for 5G technologies. Very much so, this is more about an assessment boundary. This is not, so think of some current terms of like an ATO process. This is different than things like CMMC or say supply chain security risk trying to do. I just want to note that distinction. But in this area, we are looking at, what are the current policies? What are the current, STIG, NIAP protection profiles, all the above that would apply to being able to adopt 5G technologies and incorporate it into, say, a base, that we would own, or facility or infrastructure, IT infrastructure that the government owns in some capacity, even state and local, tribal, territorial. That's an area that we're working heavily in and have been working for a bit, but we're trying to investigate this to better understand what's the implications when we start to bring in 5G technologies, those more advanced use cases in even things like smart warehouse as an example. And how does that play as far as who's responsible for the authorization, for the assessment in that regard? So those are sort of two big things that I'll note, and sort of happy to be here on the panel today. Thank you.
Thank you. Over to Dan next.
All right, great. And again, thank you for having me here. It's always an honor to be on these panels, and also with Vincent, we're doing a ton of interesting work. So I'm at the Office of the Undersecretary of Defense for Research and Engineering as part of the 5G initiative. Dr. Joe Evans, excuse me, my boss, leads the 5G initiative overall, and we split it into three pieces. There's an accelerate piece, which is deploying 5G at bases right now, and you may have seen some of the news on that. We've got smart warehouses in Coronado and in San Diego, and Coronado and Marine Corps Logistics Base in Albany, Georgia. So a lot of excitement there. My colleague Sumit Roy is leading what we call innovate, to say, look, 5G is not the end. We have to think beyond 5G to 6G, even rolling out the complete 5G standard. And my piece is operate through. And so I think that's particularly relevant to this panel, and that's where we've got some great collaboration with DHS via Vincent and other groups. So our goal is to ensure that the US military can make use of 5G resources anywhere in the world, right? That might mean bringing our own tailored environment, a private environment for tactical reasons. That might mean leveraging a commercial provider. And this allows us to do interesting things on the edge that we wouldn't have been able to do before. As Vincent talked about, we have to make sure that we can do those in a secure way. So having a process to have some kind of security assurance is critical. We're looking at things like improving security for vehicles in perhaps convoys or other activities like that, where edge computing can provide us some huge advantages. Augmented reality, virtual reality, or AR/VR was already briefly mentioned. And up at Joint Base Lewis McChord, we've actually got an AR/VR training project underway to say, how can we use 5G with the edge computing that enables all this cool AR/VR stuff to provide real augmented reality, virtual reality for the forces. And so I think we've got a lot of interesting things to talk about. I'll try not to be too long on the intro, and so with that, I'll pass it off back to Kirsten.
Thank you. And over to you, Kenny.
Good morning. Thanks for having me. So Lieutenant Kenny Miltenberger here. Always a pleasure to be on the ATARC panel. I used to be the 5G working group government lead about last year, but I kind of stepped aside once I started my new role. So my previous assignment, I was more or less the Coast Guard's Enterprise Mobility Program Manager. So we were doing a ton of work all over the mobility space in terms of unifying the Coast Guard's mobile efforts, doing software development and kind of re-architecting a lot of the things that a lot of our core applications, and writing tons of mobile policy and all that good stuff. And so my current role is I'm the Coast Guard CG Cyber's Blue Team Branch Chief. So CG Cyber is the you might think of it analogous to Fleet Cyber, Marforce Cyber, AF Cyber, the DoD cyber components. So CG Cyber, we're the analogous cyber force within the Coast Guard. The Blue Team in particular, we do a handful of stuff. So we do enterprise endpoint scanning, enterprise web scanning, internal, external. We do what I would call cooperative vulnerability assessments. And that meaning it's not a CCRI, command cyber readiness inspection. So it's not a compliance driven activity. It's a proactive activity to really, defend forward and get in front of a lot of problems. So you might even think of it, the way we provide services to the organization is security consulting. So we also provide those services pre-acquisition, or really what you might call pre-ADE 2A, where we've decided what we want and we're going to buy it. So when we're writing requirements, when we're writing the spec, we engage with the customer as well to make sure cybersecurity is built in up front. So it's a really exciting space. I have a great team. So our major initiative right now is we're actually transforming my branch to be the Cyber Operational Assessments branch, under which the Coast Guard's Blue Team will be under me, and then we'll be forming the Coast Guard's first Red Team this summer, which is pretty exciting. So cyber threat emulation, adversary emulation, penetration testing, all the really fun, good stuff. And we're excited to see kind of the fusion there too of kind of cooperative assessments plus Red Team for kind of some holistic assessments as well. So in terms of the edge computing, we've actually been providing security consulting to some of the microservice-based initiatives that the Coast Guard's working on. So maybe we'll talk about that later. But other than that, thanks for having me.
Of course, thank you. And Lindley, we'd love to hear what you're up to.
Hi, so here at Aerospike, we work on a real-time database platform that is focused at, edge to core. So ingestion of massive amounts of data, which 5G enables for sure. And doing that in a secure way and in a way that you can both understand what you've ingested and where you're pushing it to. It matters, where certain information is sent and where it's not sent, that you have specific control over all of that. And we're working on, fueling data for things like cyber endpoint testing and things like that. We have companies that are customers of ours that embed us, like Cyber Reason and others.
Fantastic. Well, thank you guys. So let's knock out our first poll question. Alyssa, if you could please pop that up. In your opinion, how far along in your agency how far along is your agency in implementing 5G and IoT? So for my friends back home, please take a moment to answer that, whether you have fully implemented, very far along in the process, have just started, have not started, or you have no clue where to start. We're going to go ahead and pull our audience. But on our panel, we're going to go ahead and discuss opportunities, potential, and the future for 5G, IoT, and edge computing. Vincent, I want to start with you. Where do you see the opportunity for the enhancement of mobile broadband with 5G and IoT in this space?
Yeah, so for this one, enhanced mobile broadband really is all about sustaining higher transfer data rates, especially in ensuring no congestion, right? So for these types of use cases, it's really about things like AR, VR, right, for training, as you can see in the DoD use cases. There's just other applications you may find where augmented reality, virtual reality do play a role. I'll note that in this case, you are seeing more of the 5G IoT more at the edge, right? So multi-access edge computing, because you want that, if you've ever used any kind of VR goggles and other aspects, you try to move your head real fast and see what does that do to you, or what does that do to the user and the trainee. You'll find that it is a challenge, right? It is a challenge if you get dizzy, if you go below a certain or go beyond a certain millisecond count. And so having that sort of uninterrupted, but more in this case, high data transfer, right? Being able to see and push high amounts of traffic. I think that's the key use case that we see within enhanced mobile broadband. I know we're going to cover more things, so I'll stop there.
Thank you. And speaking of AR, VR, Dan, I was going to turn it over to you next since you mentioned it earlier. What can we expect to see with AR, VR training for 5G, for a 5G government?
So I think this is potentially one of the most interesting applications of the 5G space, right? And because we have the edge computing, right? With that edge computing allows that lower latency. There are things we just can't get around, like the speed of light, right? That is a fixed constant. So distance matters. When you go to more of these AR, VR applications, I need that low latency, as Vincent was describing. And I can achieve that by putting edge computing very close to the warfighter, or very, very close to the end user. And so that's one of the key things that we're looking at up at Joint Base Lewis McChord. We've actually launched that, and we are in the process of deploying that now. So we're building out a 5G infrastructure designed specifically to benefit that AR, VR, that AR, VR situation. And we're looking to see more exciting stuff happening there soon. And I wanted to add in just one other quick use case, which is which are vehicles, which I think are another great example of where that latency matters, right? So with my military vehicles, or even my civilian personal vehicles, what I want to add a number of new technologies, a number of new features, from everything from reporting vehicle telematics data, my maintenance information, to automated platooning, where I have maybe a lead truck driving and all the trucks behind it are simply following along in an automated fashion, and and talking to all kinds of infrastructure. And I know there's other folks in the panel who are working on this as well. So I think augmented reality, virtual reality, vehicles are just two great examples of where the edge computing can really help.
Yeah, and I'll note, if I could, just the whole idea of ultra reliable, low latency communications in this vehicle to everything or vehicle to X is really key. I notably there's pros and cons with this, especially from a security risk side of the house. But if you just think about the type of throughput that you want from 5G, whether it's hundreds of gigabits per second, all the different type of telemetry data, and from not only from the vehicles themselves but the infrastructure, that's a lot to coordinate. And you need to have not only high data transfer rates from enhanced mobile broadband, but you need to have that guaranteed end-to-end no or latency, if anything at all. So it's really important.
So Kenny, I'm curious to hear, how are you assessing 5G edge computing from a cybersecurity perspective?
Sure. So, I mean, I think for me, a lot of it comes down to architecture is really important. And so, one, of course, you need to do the basics right. You need to, one, defend your endpoints, and especially if you're doing edge computing, is double down on the defense of your endpoints. But also that edge computing, where you're deploying it and the way you architect your software is really important too. One, just from a security perspective, but also from a usability and maintainability perspective. So, for example, what is doing the computing at the edge? Is it a mainframe? Hopefully not. You know what I mean? Hopefully it's, some kind of like, cloud type instance where, I'm not just spinning up a big chunky virtual machine and taking in all the traffic. I'm actually adopting a modern microservice architecture. And that's like one of the key, for me, that's one of the key things. It's such a complementary technology to 5G IoT and cloud, is really embracing the modern architecture here and embracing a lot of the security benefits that you can get from containers as well. I mean, yeah, there's some extra stuff you need to do, but one, you need to make sure that you have appropriate logging set up, and that whatever's doing the monitoring there is actually doing the monitoring regardless of where and how you're deploying it. And so yeah, there's a lot of interesting work to do in that space, but I would say the architecture is key to the security piece and embracing that microservice based architecture.
Great, thank you. And Lindley, for our viewers at home, how does 5G allow for pushing computing to the edge?
Yeah, so as we've discussed here, the sort of compression of latency, if you will, that 5G represents, and also the bandwidth and the more concurrent endpoints at one time that can be handled within a given network space, leads to a lot more data. Kenneth was talking about telemetry on applications and on the computers and monitoring and such. And so when you talk about pushing computing to the edge, you're talking about expanding the number of computing endpoints and pushing them away from where we monitor them to some extent. And so there's a lot of data capture that has to be going on, both locally and in terms of, I think of this in terms of data architecture because of what we focus on, right? But you have sort of multi-layered data architecture where you have data captured at the edge, data applied at the edge in real time and decisioning, but also that data has to flow back to different tiers where you may be working on truing up your AI ML models that are driving, say, an autonomous vehicle, or any other thing you're doing at the edge. So it's really going to change how people need to think about data architectures. We like to think about edge to core and all the points in between, and being able to control that data and exactly what goes where.
Great, thank you. And it looks like we have an audience question come through. I'm not exactly sure who this was for. Maybe Kenny. What's wrong with mainframes? They can support any architecture. Please elaborate.
I mean, everyone loves a mainframe. Really talking more about scalability and agility and deployability there. So, in a typical cloud environment, being able to deploy containers or serve as services, at the drop of a hat isn't maybe something you can necessarily do as quickly as to a mainframe. And so maybe you could make a mainframe support kind of cloud-based architectures, but I mean, the modern, I guess maybe more cost-effective approach is horizontal scaling instead of the vertical scaling in compute and storage. So that's really what I'm getting at. Everyone loves mainframes.
Yeah, I'd like to tag onto that just a little bit. And you know, there's a model that says that the mainframe is a model of one style of unit of composition. And it's a big unit of composition, millions of dollars when you need to add another one and you hit that breakpoint. If you get your unit of compensation correct for the application you're doing, and what we're talking about here is pushing things to the edge. So some compute moves to the edge, some compute moves to middle tiers. The mainframe still has a place, you know, and there's probably 30, 40, 50 years of accumulated knowledge in the code that exists in the mainframes. That's not going away. We have to figure out how to fit that into the architecture. But this unit of composition model, as we have to scale out from massively more computing, needs to be adjusted.
I love that answer, by the way. I think that's awesome.
And I want to just chime in on that as well, because I think it's actually a great question. So I'll give a little bit of a sarcastic answer at first as someone who started their career working at supercomputer centers. It's really hard to get those Cray YMPs up on the cell towers. They just don't fit well on top of a tower. But a more serious answer here is what Lindley and Kenneth have already sort of alluded to, right? Is we need to think about the architecture as spanning all the components, right? I can do my IoT device, I may be able to do very limited power, very limited computation. My vehicle, I can do a little more. With the edge computing, I can distribute some of the work there. I can push additional stuff back to, I'm not at all taking away, the back-end data centers and the mainframes. Those are going to be essential, but we need to think across the entire environment. And so challenges that you might have said, if I tried to do my AR VR training by pushing everything back to a data center in, from Joint Base Lewis McChord in Washington State back to a data center in the Pentagon, right? I'm stuck with a number of challenges just in terms of bandwidth, in terms of latency. It's just not going to work well. But if I can distribute some of those key aspects out closer to the edge, almost all the way to the edge itself, and combine that with back-end processing that might be happening back at that data center, I think I have the most powerful infrastructure. So I think it's not an edge or core discussion. I think it's, how do we fit them all together and that's where the opportunity is. Thanks.
Thank you, guys. And Vincent, how will 5G and IoT affect law enforcement in the state and local? Muted.
You're on mute.
There you go. So in this case, given DHS's mission, we do have, everything from Customs and Border Patrol to, ICE, FEMA, others. So that we do have a really good, diverse mission set to protect the homeland. I'll note that there's a variety of potential applications. So by all means, I'm not speaking on behalf of CBP or ICE or any of the others. However, if you do think about more 5G at the edge compute and IoT specifically, it's really about being able to ingest the sensors that you do have available to you, right? And so in this case, if you apply things like augmented reality, where there may be sensors within the infrastructure at the border or other aspects that can be relayed and provided to you, where you don't have to process that back at a data center, I don't know, Pentagon, whatever equivalent in DC is. But the idea here is you are able to leverage sensors that are out there in IoT, have that not only the high transfer data rates. Hopefully with 5G, you also have that security aspect, right? If you apply the right standards to this, you can have things such as, ensuring that your unique identifiers are not, not compromised or not distributed or unauthorized disclosure. But the other aspect of, if you think about 5G, there is also the other, lawful interception pieces, right? That are actually built into the protocol per the law. So I think that for us, you will have the traditional enhanced mobile broadband, the ultra reliable low latency, and even as people try to get to the massive machine type communications, I think we're going to need to be more along the lines, when we say it for us, it's really the 5G advanced use cases, not your more, traditional. And the reason I say that is because you're going to see much more opportunity and benefit for these potentials in the 5G standalone systems. Right. So specifically, when we start to virtualize the RAN, and have things like network slicing availability, so that, hey, if there's something for law enforcement, maybe we can put, rules around this. Maybe we can apply this in the 5G IoT edge compute scenarios that really enable our mission to ensure the border, to ensure, various, emergency management law enforcement scenarios.
Thank you, Vincent. And Dan, I think you alluded to this earlier, but I was going to ask you the question, is edge computing, in your opinion, a security challenge or more of a security advantage?
That's a great question. And I think it's a bit of both, right? It mainly changes the way that we think about security, and I would claim it maybe offers us a few more advantages than it creates in terms of problems. Right? So back to our discussion of mainframes, or tying it back into that a little bit, right? It's a different model if I'm securing my data center, right? If I have a small number of data centers, I can have good perimeter security, good physical security. We know how to do that, right? We still have to worry about all of our virtual cyber attacks, but we've got a centralized place. And that's great for physical security, that's great for monitoring. With edge computing, right, with the MEC, we've pushed stuff, as the name says, out to the edge. Right. And there's a lot of edges, right? So it's not that I'm pushing out to one location at the edge, I'm pushing out to multiple locations. And while it might be tempting to think from a security standpoint, oh, it's easier to secure a single point, right? We also have the concept of single point of failure in terms of cybersecurity, right? And that's all of our security people should be like, oh yeah, right. Single point of failure is something we want to avoid. The edge computing gives us the potential to do interesting monitoring close to the edge, interesting processing close to the edge, interesting resilience and redundancy for failover. So I think if we do it right, it actually can improve our resilience, not resilience and security, not harm it. And so I think that's sort of the way we'd like to approach the edge computing as more of a potential advantage.
Thank you. And Kenny, back to the cybersecurity perspective, what opportunities for changes in implementing security does 5G and IoT allow? And do you have any specific examples from the past that you know of?
So as Vincent alluded to, I think some of the slicing technology in 5G is really interesting as it comes to implementing security. I mean, I'm sure there are ways you can do that to either I have my own private slice, or maybe there's a government slice or something like that that affords me a little extra protection there. The IoT security is actually particularly interesting and really, really hard. There's been a lot of research on some really interesting topics like moving target defense, if anyone's familiar with that. I've been reading some papers about that, where I'm randomizing my network layer or my network addressing either based on inputs that are coming in or just randomly in advance. And so, you might think of it as like a security through obscurity, but again, if you put your red team hat on, the thing we normally rely on is static networks. I know this IP, this host is going to, have this characteristics. And when I go and scan to exploit that, and now it's not the same host, or it's feeding me incorrect data, oh gosh, well, I got to completely change my attack patterns there. So I think that's really challenging. The one thing I want to add to the security and the edge computing is not to discount the physical security aspect. And that kind of comes down to, the data center, yeah, you have your nice ball. And in my opinion, the biggest security advantage to the data center ball is the physical security of the data center that you own and secure. Everything else is like, we want to move to zero trust anyway. We don't want to trust any of our endpoints, whether they're servers or user endpoints or something like that. And so I think that's all good. But it's really, if I'm a large organization and I'm scaling, and either I own some of that edge compute infrastructure or I don't own it, maybe that physical access might actually be the way in, because I'm so distributed, I can't maybe monitor or control or have as much fine control over that physical access to lead to the cyber effect.
Great, thank you so much. Lindley, last question, focused on opportunities before we move on to risks and challenges, but what changes should we expect to see with data centers, and what about data in general?
Yeah, so we've touched on this a little bit, but you know, data centers are becoming disaggregated, I would say. You know, you have to look at your total fabric of data centers, if you will, right? There's, you know, we have endpoint devices. They're part of the computational space now, and you have to look at them individually and in aggregate. Then with 5G, you know, when we think about this, we used to have very dedicated hardware for networking, for things. Now it's all, you know, the same chipsets and such, and it's software defined. You know, it's software defined both at the cell tower, both at the micro data centers where, you know, the signals are concentrated and processed and you know, put back onto fiber potentially. And we have to be able to deal with that. And that gives you an opportunity to start distributing data at multiple points. You know, latency still matters. You know, 5G solves a great last mile piece, but if you can keep distributing the data to the right places so that you have that also gives you a level of resilience. I think Dan has touched on this some, that, you know, if you have many points where you have the data and you can fail over to that as a backup, but it's used primarily for performance, you can limit the blast radius, right? If somebody attacks one point or one region or one area, you can also drive that traffic back to other places. And thinking about this is not, you know, we used to think about the data center, build walls, save that. Now we have to think about the way people think about composing cloud, right? You know, it's not that Amazon or Google has a perfect computing space. Nodes go down all the time. Network connections drop. There's so much redundancy built into it, though, that those are little blips. And if you build your software for that model, you can keep going. And that's what happens. But with that, you have to make sure that the right data is distributed to all the right places, and that you're consuming data from multiple places, and any one failure doesn't really stop the application or the mission.
Thank you so much. Alyssa, if you could please pop up our next poll question, we're going to knock that one out. In your opinion, how much has working remotely affected mobile and IoT when using Edge? You can answer greatly affected, slightly affected, not affected, or you don't know. And right before we move on, I did see an audience question come through. What are the pros and cons using 5G network slicing to improve cybersecurity? Which panelist would like to answer that one?
I'll take a first shot at that one, and I think everybody might want to weigh in on this one. All right, so network slicing is a really interesting opportunity for cybersecurity, right? But I don't think we know what the answer there is. So just to, you know, I think everybody on the audience knows this mainly, but you know, network slicing allows us to create sort of a virtual infrastructure on top of the existing infrastructure. Almost, you know, I like to use the analogy of almost like running a virtual machine on my laptop, right? So there are benefits to that, and we understand how to do that in terms of performance. I can get myself a network slice to say, you know what, Dan's application, I've got a machine-to-machine application, and I need a latency of X and a bandwidth of Y, and a network slice can give that to me. Right. And so slicing is, in that sense, a really good technology. Now, the question here is, I don't want, in my network slice, I don't want a specific latency or a specific bandwidth. I want an added level of security. There's pieces that are easy to do to say, hey, everything on my network slice has the following types of encryption, or that, you know, that I can do. The more interesting thing is in terms of that availability and observability. Can I build a network slice that has a higher level of availability for one of Vincent's you know, homeland security applications, for a military tactical application? And I think I'm a believer that we can do that, but I think the jury's still out on that. We haven't sufficiently proven that we can make a secure network slice, although I think there's a lot of potential to do that. And I'll see, so I think potential there, but more work needs to be done.
Yeah, I'll just add or note that, my analogy is a little different. It's same concept, but if you think about firewalls and server farm firewalls, you think about every VLAN is potentially its own slice. You can apply specific rules to that VLAN, and then great, we have multiple slices. What's different about 5G and how this, when you look at virtual and more network slicing, is that there's a combination and a need for things like machine learning and artificial intelligence to be able to pop up a slice and take down a slice as needed, right? And it's not something where you're going to go with a manual operator and start to designate these things, because you may have something related to law enforcement or banking or medical or whatever the pieces. But now when we think about, how does it work between slices? Is there any risk? Because it is virtual now of like, if I'm in one slice and it's less secure, can I jump to another slice, right? And so a lot of these things are still being teased out and still being worked through per the standards, per research and industry. But I'll say that, as standalone technology comes on board, I think you're going to see much more of these capabilities. So there's pros in that, a lot of potential as you can think about a server farm firewall and a VLAN being able to apply. Now the cons being that, okay, great. Now what about the underlying sort of machine learning, artificial intelligence that backs this up, or even between slices and how that works interoperably? So those are key pieces, I think, that applies to both pros and cons of this, which honestly will be worked through and worked out. I honestly believe in the future and the years to come.
Yeah, I would add one thing to this conversation that, because as you point out, Vincent, all of this is software defined now. I mean, networking has changed greatly, and the 5G implementations are almost purely software defined, which means that at every level, on the cell tower, right, at the micro data center when things are aggregated, it's software. It's software running on an operating system. And there is a security perimeter everywhere there. And all of that has to be hardened and it has to be focused on there, because whatever you do with encryption and the software defined piece to get that slice, if the core components of computing are not secure, it doesn't matter.
And yeah, if I can add, I don't think the security benefits to 5G slicing is a technical problem. I think we have all the tools in place to implement secure 5G slicing and use AI and do all sorts of crazy stuff. I think the actual problem, or at least in my opinion, is a very human problem, is if I'm the government and I want to leverage a private slice on a nationwide commercial network, oh gosh, what an administrative nightmare. That's like, that could be really hard, and let's say we want to work cross carrier, and then validating from the government to commercial that it's implemented in the way I expect it to. If I'm let's say deploying my own private 5G network on a base or in a hospital, I think secure slicing, oh yeah, absolutely, no problem. I have control top to bottom. I think it's once you start opening your aperture to where you're implementing the slice, it becomes the human problem.
So we had an audience question come in, and I think it makes sense since we're going to be discussing challenges and risks. Carolyn asks, keeping only needed data at the edge is one solution, but there is a problem of update and frequency. How can these be resolved? Anyone want to tackle that?
I'll take that because that's a lot of what we focus on. So I mentioned that with this change in the model of computing, right, you're actually needing to put the data close to where it needs to be used. So to deal with latency problems, to deal with blast radius so that it can operate when only parts of the network are there and such. So really having a clear plan of how data gets distributed, and how you control it. In the commercial space, we sort of think of this in terms of like GDPR. So for global companies, they're always trying to figure out, what can I send where? What do I need to send where? And is it there and current, right? And we talk about real-time data, and real-time has a sort of hierarchy. It can range from a day to, microseconds, right? and being able to know where you have what data and the currency of that data is critical to successful applications built for these distributed architectures.
Thank you, Lindley. So moving on, Vincent, what risks does edge computing pose when it comes to attribution and privacy?
Yeah, so this is a great way to plug in CISA. So CISA.gov/5G, you can see our various publications. There is one specifically titled Overview of Risks Introduced by 5G Adoption in the United States. I'll note that this covers security risks and threats, right, needed to be studied and understood in the 5G endpoints, the UE side of the house, and their applications, 5G access network, and 5G, MEC subsystems, 5G core network, and supply chain. Since this panel is really about the MEC, right, multi-access edge compute, and the focus here, I'll just pull out a couple key things. So when you think about a multi-access edge compute subsystem, this expands the 5G threat surface with additional modules, interfaces, the operator and the operator provided models, such as third-party non-mobile carrier applications and edge compute cloud providers, right? So just think about, as you bring all those things up, you talk about the maintenance of that, the software that rides on that, and then the even subsystem that you bring involved in this multi-access edge compute capability. Now you're concerned on what is being brought in, right? This is where the concerns, it is related to supply chain in this regard, but that poses, significant, security risks and challenges. Not that it cannot be overcome, but you have to do your due diligence as you bring that capability on. I'll note that also when you think about other examples, and this is things where it relates to like vehicle to X, right? Everything. This does require things like AI and machine learning in the MEC, system itself, where now you think about AI and machine learning, that itself poses potential additional security vulnerabilities and risks associated, as people might know. So I just want to note those key things, but again, plugging the CISA.gov/5G, you can see our paper on overview of risks introduced by 5G adoption in the United States.
Awesome, thank you. And Dan, previously we discussed the future of edge and what we can expect to see with AR, VR, and 5G government. What specific challenges, risks do you think come along with this type of technology? And also more specifically, what are the security risks and implications?
So strongly reinforce a lot of what what Vincent said about the security risks, and some great resources to look at there. Right. So one of our challenges here is really going to be in terms of availability and observability. Right. So these are two things that kind of keep me up at night. Is the more I build out these systems, the more I become dependent on them, and then I can get into a lot of trouble when they don't work. I can see some great examples in the vehicle space where now I've got a tremendous improvement in terms of autonomy, reducing. I can put my convoys much closer together because now we're automated. Only the lead truck is driving, or not even the lead truck's driving, and I'm talking to all this vehicles, all the roadside sensors. And all that's a great feature until the feature is not there, right? And so what we have to do is we have to be able to make sure that as we build this out, we don't become overly dependent on the availability, and or we ensure that, as Lindley kind of pointed out, we rely on the fact that we have that contained blast radius. So I might lose some availability in one area, but be able to fall back onto availability in other areas. So one of my biggest concerns is the availability. The other one is observability. And so part of what I'm chartered to do is to allow DoD to operate anywhere in the world, leveraging whatever infrastructure we can use, right? We often make the analogy in terms of the road infrastructure and the power infrastructure, right? If DoD goes to conduct a mission somewhere in the world, we don't start by coming in and building our own roads and bridges. We don't necessarily start by coming in and saying we need to deploy our own power infrastructure. Now we have the ability to do that, right? The Corps of Engineers can span a river anywhere in the world, right? Forward operating bases rarely depend on host country power, especially in contested areas. I want to do the same thing in 5G. I want to be able to, of course, bring my 5G capability anywhere I go, but leverage that 5G capability, that's the infrastructure that's already there when it makes sense. And one of my biggest worries on that is the observability of the data. Just by looking at the communication happening, by looking at how I'm making use of the mech, how much can you learn about my operational tempo just by observing the data? And I'll one last thing, and then I'll pass it off to other panelists. Is the cheap analogy there is what we sometimes call the Pentagon, the pizza delivery to the Pentagon problem, right? So what can I learn from by operational tempo just by watching, watching food deliveries in and out of an area like the Pentagon? No classified data has been compromised, but it could potentially tell me quite a bit. So as I'm operating on these commercial 5G networks in my own secure slice or in some other scenario, I worry about how do I protect against the observability. And I think we can counter that, but I think it's something we have to pay attention to. So thanks.
I love that, by the way. Dan, are you a electrical engineer type? Are you like a control theory or information theory guy? You're just, talking about observability and like, information and entropy ideas. And I'm like, oh man.
I do very much. I'm guilty of some of that, definitely.
Okay.
I was just saying you just need a mobile app that everybody uses when they run, right? And have geolocation turned on, not to put a pun there, but yeah.
Great. So we're going to take a quick pause to knock out our last poll question for today before I forget. On a scale of 1 to 5, how confident are you in your agency's ability to provide a secure technology infrastructure? Extremely confident, very confident, moderate, slightly, or not at all confident. So please remember to answer that if you would like to receive your CPE credit for today. Kenny, I'm going to turn it over to you. What are the challenges, risks associated with overcoming culture and change in a way of implementing such services that we've discussed?
Oh yeah, I love that question. Yeah, that's I think that's like the biggest barrier, and it's the great it's the great challenge to modernization for us. And so if you for me, you think about mobility, just in general, I mean, and this kind of can apply to other areas, but for me, I think about the device, I think about the infrastructure, and I think about the applications, and you can really think about that as like your total computing experience. So part of the challenge we have in government is that the teams that do these three things are often extremely disparate, maybe never talk to each other. And it can be really hard to create a comprehensive strategy that spans all three tiers, the entire computing experience. And so, this kind of gets to also questions about like, okay, so if I'm kind of walking this back. So edge computing, if I'm doing edge computing, I want a container-based architecture. Awesome. Okay, so if I'm doing a container-based architecture, I probably need to implement some kind of DevSecOps, because so I can do rapid deploys, so I can be agile, so I can continue developing. And if I want to do DevSecOps, I need to completely change the way I manage IT in my organization, and not just manage it, capitalize my IT in the organization. So in government, we love calling projects done, right? It's like, oh, we built that application, see ya. It's not like Netflix where their application is their moneymaker, and they're going to keep developing it, improving it no matter what. We have the opposite problem is we want to call it done and we want to stop spending money on it. And so for me, one of the things I think about is, let's say I'm a government agency that's pivoted to a microservice architecture so I can do my edge computing, so I can leverage the goodness of 5G and all that stuff. So what if I pull funding for one of those systems, but my microservice architecture has microservices that are reused throughout the entire agency? If I'm the Coast Guard, I want to build a microservice that like gives me vessel information. Gosh, well, how many other use cases are there for that in the Coast Guard? A bazillion. So if I kill that project, do I also kill that one core microservice that has a ripple effect on everything else? And so that's also part of the culture, is part of the management piece of how do we manage and treat these modern architectures in the government. And my suggestion is you capitalize the microservice architecture. That is a core asset like a cutter. That is a system in and of itself, and you keep money for development of that thing. But that, I think, it's requires a ton of top-down direction, and it requires a lot of education and understanding for a lot of people who are sometimes entrenched in the way things should be. I should have my monolithic application that just lives in this data center. And so it's total culture revolution, but needs to come from the top and be driven hard.
All right, thank you. And we had an influx of audience questions, so I want to try and get to as many of these as we can. Lindley, maybe you want to tackle this one that I'm looking at. Has anyone come up with a good way of tracking currency need and moving data to the edge as required? Any thoughts around that?
So this is really, from our perspective, it's a change in how we look at data, and there's a concomitant thing. Kenneth was talking about microservices and the application piece. There's a piece that goes along with that in terms of data like this. So how do you track it? So what we tend to do, and what we see, is that people want to understand provenance of data, want to be able to control where it's pushed, because it used to be it all came into a data center and it was there. It was in a data warehouse. That's not the model anymore. The model is that the data needs to exist where the decisions are happening. That, one, that makes it more resilient. Two, it makes it more performant. And so you have to be able to just have the metadata to understand where you're pushing things, but also at every point be able to control what goes where. Okay, and that's a big part of security too, because once we open these doors where it gets pushed, we're pushing pieces of data, but people can aggregate that into a fuller picture. We may not think they have access to something that's all that meaningful, but as they piece together parts, it creates a different picture. So I think that just having the visibility and the observability into what you're doing, where data is going, is key to that. And being able to take advantage of all of the different distributed computing pieces like Spark, Kafka, et cetera, to be able to distribute it, but to know what you're doing. We find that that's one of the toughest things to handle, to know what you're doing actually, and to know what you've done.
Yeah, from the government side, if I could add, I think that there's also why there's a need, and there's been a big push for chief data officers, right, within federal government, being able to identify and tag sort of not only the value of the data, but the timeliness and more appropriateness of the data. I do think that when we start to go that way, and I think we are, the use cases are what drives determining how this could be tracked, how this could be defined, how this could actually be implemented. But again, I think with the government push, the chief data officer and all those pieces you probably heard with DHS that being pushed and named, those are aspects that I believe that really will drive our ability to look at data in a different way than we traditionally have.
Thank you. I'm going to throw out another audience question. Are there standards for edge computing such that I can mix and match edge compute vendors and cloud providers? Insights on that from our panelists? We may have some stumped. Oh, Vincent, he's got it.
No. So I'd love to know if you have like the silver bullet on this one, right? So there definitely are aspects of international standards, 3GPP and others. Specifically in the IoT space, there's some NIST standards. I've seen stuff from, CTIA Wireless Association. I've seen all types of pieces, but who owns it and what's the definitive, standard that mixes and matches? I mean, cloud, that's more FedRAMP for federal government. I'll note that. But when you start to mix and match and you start to say, hey, well, okay, now when I say, something as simple as, IoT and 5G standards and how we're going to apply this, then, the question comes in, who's the governing body that everybody's going to follow? That becomes a hard one, at least for on my side, that I'll say that.
Yeah, well, this is a huge problem. I have a lot of experience with IoT going back to dealing with asset management on, offshore oil rigs, on onboard ships, et cetera, right? And the problem is that every type of equipment sort of has its own standard, if you will. So what's happening to some extent is a move towards self-describing data, as far as interchange, right? So that you can parse it and understand it at the point of its use, right? And that's sort of the only hope right now, because there are too many things in play now to just have one standard. So self-describing data, meaning whether it's, I just use the, sort of like XML or JSON or something, but having something like that so that you can parse it at the point of reception winds up being key. Otherwise, you have to build a bunch of software to build a multiplexer for everything with IoT, and that's just not going to stay current.
Great.
Yeah, and I'll just do one quick sort of tangential plug for. So Vincent actually started some of this work, and Vincent, I may be expanding the scope of that security assurance process a little bit. But I think one key observation is that we are going to need to do a better job developing, security assurance processes, and how do we mix and match these things, right? So that's a question that I would love to be able to say, like, yes, here's the answer. It's 2 parts of X and 3 parts of Y. I don't think we have that answer right now, but I think we want to get there. And I think what Vincent started at DHS, and it's got DoD, CIO, NIST, my group at OUSD, R&E, looking at how do we actually, for just the 5G ecosystem itself, how do we start to do this so that we're not starting from square one every time we pull in a new system and every time we connect a new piece in there? So.
Yeah, the key thing is a repeatable process, right? And definitely we want to make this work for everyone so that you can incorporate 5G technologies into your mission. But I will say, in just, you think of enterprise mobility, you think about cloud, you think about 5G, the taxonomy in these areas, even if you just pick one, is very, very depressing if you look at it too long, right? And so I'll just note that those are huge hurdles and challenges, which I think are being looked at and are being addressed, but they are still being addressed sort of in silo, right? If you do take a look at what is being required, it is a tough challenge, but it is being worked. Kenny, go ahead.
Oh gosh, well, getting to kind of the security piece of that, I think one thing we want to think about is a drive toward operational cybersecurity and operational testing. STIGs are super important. Scanning and patching is super important, but to a certain extent, let's say I'm an IoT device out there. How often are you going to get to patch that? Yeah, especially if it's a firmware update on a teeny tiny like TI MSP 430 or something. And so you're going to have to start implementing defense in depth where you're just not going to be able to patch, or you're not going to be able to do some stuff that you would normally want to do. So, that's where I think, especially when we consider new security processes for evaluating, where's my boundary for my 5G, microservice cloud, ecosystem. I think a lot of it's going to come down to the comfortability and real operational cybersecurity testing. How's your defense in depth? When you start throwing bits downrange at it. So that's my take.
Thank you, guys. So we are running up against time. I want to give each of our panelists an opportunity to leave the audience with some closing thoughts. While you're giving these closing thoughts, keep in mind, based on all the situations and factors we've previously discussed, what do you think agencies should be doing in order to prepare themselves for the future of 5G and IoT? And how should they be prepared to mitigate the risks associated? So closing final thoughts, can we please hear from Vincent first, and then we'll go around?
Sure. So I'll just put a plug in. Look at resources as like CISA.gov/5G. I'd also take a look at NIDRD's Advanced Wireless Test Platform Group, led by Dr. Sumit Roy, and Dr. Melissa Metzer, if I said that correctly. And so those two groups those resources are great. Also within Federal Mobility Group that's chartered under the Fed-CIO Council for federal government looking to engage, exchange information, look at lessons learned. Even for industry, if they want to, look at what emerging technology can apply to different use cases in 5G and others for federal government. I'll say email wireless at gsa.gov, and you can also look at cio.gov. Those are great resources and ways to engage.
Thanks, Vincent. And over to you, Dan.
Great. So I'm just going to stress sort of the use cases. So I think one of the best ways to engage with a group like the 5G initiative over at OUSD R&E is if you have a use case, we're very interested to hear it. We're rolling out these cool things at the various Tranche 1 bases around the country. We're working with our international partners. But a key driving factor in there is coming with, especially from a DoD angle, what is it that we need as a driving use case? Building out a secure 5G network for all applications and all purposes at all times is a bit of an unachievable task, right? So it becomes much easier to work with, and we potentially have resources to help roll some of those things out if we have a specific use case. So happy to talk to folks about, what are your use cases? I like AR, VR, vehicles, but what we really want to do is hear from from the operational folks is, this is where we really are experiencing pain points or where we really see opportunities. So focus on the use cases, I think, is the main advice for me. Thanks.
Great. Thank you, Dan. And over to you, Kenny.
Thanks. Well, thanks for having me. My main advice is to help drive the culture change. Understand the technology at a level where your executive leadership can understand. If you are an executive leader, help try and understand the technology and how it can really, really benefit you and the organization, and help your peers who may or may not be entrenched in the old way of thinking understand the benefits of kind of the big culture change of embracing all these new things. And I think, for me, that's something that that would be incredibly beneficial. So again, thanks for having me.
Thanks, Kenny. And close us out, Limley.
Yeah, so thanks for having me as well. And I'll say this, I was really struck by what Kenneth's focus on the sort of human side or the cultural side. But 5G is going to mean more distributed applications, and distributed applications are different. Okay, they are distributed. There's not one thing. There's a lot of dependencies built into it. Okay, so the notion of looking at streams of information, not information statically in place, that the notion of looking at streams of value in terms of applications, that it's not a point in time thing. It's something that's constantly adapting. These systems move on, and the notion of budgeting for them differently, that's already happened on the commercial side with very large applications. I was at Oracle for years, and we spent a lot of time looking at the change in financial models required to go into a different way of delivering technology. Each of you, when you engage with commercial vendors like Aerospike, don't look at buying a database point in time. You look at a relationship with a company that's going to provide a stream of technology to you that's going to evolve as 5G hits and we learn more about it and things like that. So I think this notion of shifting the point of view to something that's always adapting, always changing is key to success with 5G, or really technology these days.
Awesome. Great way to end it. Thank you again to our panelists and everyone at home. I want to thank our partners as well at Aerospike. We hope to see you guys next week for our May 26th webinar event from 10 to 1 p.m. Eastern Time for ATARC's Hyper Automation Summit. Oh, this is actually the launch of a new working group that we're going to be hosting ATARC focused on hyperautomation. So I'm sure there'll be more discussion around that, and please go register. The summit has panels discussing how automation is proving to be a means for true digital transformation and is improving employee experience, transforming citizen experience, and trusting automation in federal IT. As you can see, we have a great lineup of panelists for that one as well. So we hope to see you there, and everyone have a great rest of your day.
Thank you.
Everyone.
Bye.
Thank you.